Hello to everyone. In this video, let us discuss variation of ionization potential in a group and in a period, and some important aspects regarding which one that ionization potential. So already we know the definition of ionization potential. What is that? The minimum amount of energy required to remove outermost electron from a neutral gaseous atom is known as ionization potential. What are the units of ionization potential? Electron volt per atom, or kilocalorie per mole, or kilojoule per mole. And 1 electron volt equals to 23.06 kilocalorie per mole, or 1 electron volt equals to 96.43 kilojoule per mole. So these are the units of which one ionization potential. Now let us see what is the variation of ionization potential in a group. Okay, now in a group from top to bottom, ionization potential, what happens, decreases, because we know that from top to bottom in a group, what happens, atomic size increases. As atomic size increases, nuclear attraction on outermost electron decreases. So in this case, less amount of energy required to remove this electron. So like that, as atomic size increases, ionization potential in a group decreases. So this is variation in a group. Now let us see variation in a period. In a period from left to right, what happens ionization potential? So controversial to that variation in group. Now in a period from left to right, ionization potential increases. Why? Because in a period from left to right, atomic size decreases. As atomic size decreases, nuclear attraction on outermost electron increases. So we have to provide some extra amount of energy to remove that electron. So like that, in a particular period from left to right, ionization potential increases. So in every period, first A group element is having less ionization potential, and zero group element is having highest ionization potential. Of course, in case of some elements, some irregularities are there. This trend is not in sequential order. That means from left to right, IP increases means in some groups, or in case of some elements, some irregularities are there. What are that irregularities? Especially second A group and fifth A group, and of course zero group is having, we know that highest ionization potential. But in case of second A and fifth A, we can observe some irregularities. That means this fifth A and second A group elements having more ionization potential than which one that adjacent group elements. For example, in case of second A group, if you consider beryllium second A and boron belongs to third A group, as per our description, beryllium ionization potential should be less than that of boron, but this is not the correct one here. Now that experimental values shows that IP1 of beryllium greater than that of boron. So why it happened like this? Because beryllium has 2s2 configuration, boron has 2s2 2p1 outer configuration, outer electronic configuration. In case of beryllium, we have to remove the electron from high penetrating powered S subshell. But in case of boron, we have to remove electron from less penetrating ability p orbital. So as usual, we know that we have to provide more energy to remove electron from S subshell. So beryllium IP1 greater than that of which one? Boron. So after removal of one electron, this configuration will become 2s1, this configuration become 2s2. That means beryllium plus 1, beryllium plus 1, boron plus 1 if you consider. Now that IP2 if you want to discuss here, second ionization potential of which one? Beryllium plus 1 is less than that of boron. Second ionization potential of beryllium is less than that of boron, because after removal of one electron, now here 2s2, that means paired electrons are there, but here a just unpaired electron is there. So like that, second IP value, if you consider second IP of beryllium less than that of boron, but if you come to first IP, beryllium first ionization potential greater than that of boron. So this is somewhat irregularity in a period. Similarly, we can observe the same issue with 5th group elements also. If you consider nitrogen and next 6th group element oxygen, as per our description, nitrogen ionization potential should be less than that of oxygen, but the experimental value shows that first IP of nitrogen, IP1 of nitrogen greater than that of oxygen, because nitrogen outer configuration 2s2 2p3, oxygen outer shell configuration 2s2 2p4. So half-filled configuration is more stable than incomplete electronic configuration. So as nitrogen is having half-filled electronic configuration, we have to provide some extra amount of energy to remove the electron from nitrogen. So that's why only IP1 of nitrogen greater than that of oxygen. But after removing one electron, this configuration becomes which one? 2s2 2p2. This oxygen plus configuration becomes 2s2 2p3. That means after removal of one electron, oxygen will get, that means unipositive oxygen is getting half filled configuration, and unipositive nitrogen is getting incomplete octet configuration, incompletely filled configuration. So that means now if you come to second ionization potential, nitrogen second IP less than that of which one? Oxygen. So like that, some irregularities in ionization potential variation in a period in case of second A and 5th A group elements. So this is regarding variation of ionization potential in which one means in a group and in a period. Later, what are the some important questions we have to concentrate regarding ionization potential? So what are the questions we have to concentrate here means, they give the formula related questions. They give IP1, IP2, IP3, so on like that values. Based on that variation of IP values, we have to find its formula of chloride or oxide or any formula. So now let us see one example here. For example, for an element M, IP values sequence is like this. IP1 less than, IP2 less than, IP3 less than, IP4, so on. So what is the question now? What is the chloride formula of M? Or what is the sulfate, nitrate, phosphate formula of M? So now based on this trend, we have to that means we have to find the group number of this element M. So let us see how to find out here. IP1 less than IP2 less than IP3 means there is a sudden gap in between second IP and third IP. So a first simple formula for that, how to find out group number means in between after which IP, after which ionization potential there is a sudden energy gap or there is a much energy gap, that element belongs to that group number only. That means after second IP there is a much energy gap, means this element belongs to second A group. How we can say like this means, let us consider any second group element magnesium. Its configuration neon 3s2. Now here by providing some heat energy, first electron may be lost here to give Mg plus, configuration will become neon 3s1. And by providing some more extra heat energy, this electron also has been removed. Now that became Mg plus 2. But in case of Mg plus 2, that configuration is nothing but neon configuration. So first two electrons that of course that almost lose easily. But if you want to remove third electron from Mg, that means magnesium, or if you want to remove another electron from Mg plus 2, it is somewhat difficult, because after losing two electrons, magnesium got inert gas configuration. So it is not interested to lose electron now. That means here to remove another electron from magnesium plus 2, we have to provide somewhat more and more extra heat energy. So that's why only in case of magnesium, if you consider, there is a sudden energy gap in between second IP and third IP. So after which IP value there is a sudden energy gap, we have to observe, we have to assume that as the group number. That means after IP2 means second group of second A group. After first IP sudden energy gap means first A group. After third ionization potential if sudden energy gap means third A group, like that. So now as second IP, third IP having much energy gap, this M belongs to second A group. Means what is the charge we are expecting on that M means plus 2 charge. Now if M is present in plus 2 charge, what is its chloride formula? Chloride formula means M plus 2 Cl minus. So in crisscross method, we able to write the formula. What is that? MCl2. Okay, then its sulfate formula means M plus 2 and SO4 minus 2. Plus 2 minus 2 charges if get cancelled means we get the formula MSO4. And what is its nitrate formula? What is its nitrate formula means M plus 2, M is present in plus 2 state and nitrate is present in NO3 minus. So M plus 2 NO3 minus. So what we can get the formula now? MNO3 taken twice. So like that they give which one? Trend of IP values. So like that IP1 less than IP2 less than IP1 less than IP2 less than IP3 less than IP3, like that. So where there is a sudden energy gap, after which IP there is a sudden energy gap, that element belongs to that particular group only. So like that. And sometimes instead of giving that IP order, they may give values. So how to solve now that type of question? See here. For an element M, IP values are like this. What are the IP values? 40 kilojoules and 60 kilojoules, 90 kilojoules, 800 kilojoules, 840 kilojoules, like this. Now what is the group number of that element? So let us observe that what are the IP values here. What are the IP values? First IP 40, second IP 60, third IP 90, fourth IP 800. Of course, in between first IP, second IP and second IP, third IP, some less energy gap is there. But after third ionization potential, there is a sudden energy gap. So this value suggests that this M belongs to third A group. Therefore, and its valency is M plus 3. Therefore, its chloride formula means we can give MCl3. So this is regarding which one here? Ionization potential and variation of ionization potential in a group and in period, and writing the formula using the ionization potential values. Okay, now let us see another periodic property, electropositivity. So what is electropositivity means here? That means the tendency of an element to lose an electron is known as electropositivity. The tendency of an element to lose the electron is known as electropositivity. So in a group from top to bottom, as atomic size increases, electropositivity also increases. So in a group from top to bottom, electropositivity increases. And we have to remember one thing, electropositivity is the characteristic property of metals. That means here, as electropositivity increases, metallic nature also increases. That means in a group from top to bottom, both electropositivity and metallic nature, what happens means increases. But in a period from left to right, these two values, what happens means decreases. Because in a period from left to right, as atomic size decreases, its that means electron losing tendency also decreases. So in a period from left to right, electropositivity and metallic nature decreases. Metallic nature decreases means non-metallic nature increases. From left to right in a period, electropositivity, metallic nature decreases and non-metallic nature increases. So this is regarding which one? Electropositivity. The most electropositive element in periodic table is which one? Means cesium, because cesium is present in first A group at the bottom. So from top to bottom we know that electropositivity increases. So cesium is having highest electropositivity, helium is having least electropositivity. Okay, this is regarding which one? Electropositive character. Okay, now let us see another one here, electron gain enthalpy, or we can say that as electron affinity also. So electron gain enthalpy means what here? If any non-metal is gaining one electron, it will become which one? A minus. And at that time, some heat energy is liberated out. That is known as first electron affinity or first electron gain enthalpy. So what is the definition? The amount of heat energy liberated when an electron is added to neutral gaseous atom is known as first electron affinity or first electron gain enthalpy. But now if you go to second electron affinity, A minus plus electron gives A minus 2. This is known as second electron affinity or second electron gain enthalpy. But for any element, first electron gain enthalpy delta H value is negative, but second electron affinity value is positive. So why happen like this means, in the case of first electron affinity, it is easy to add electron and due to that some energy will be liberated. But if you want to add second electron, there is some difficulty. Why? This A minus is having negative charge, electron also having negative charge. In between electron and A minus, there exists some repulsion. To overcome that repulsion, this time we have to provide some heat energy. That's why only second electron gain enthalpy is positive, but first electron gain enthalpy delta H value is negative. And what happens in a group and in a period? Variation. Let us see here. So, variation of electron affinity in a group, let us see here. In a group from top to bottom, in a group from top to bottom, electron gain enthalpy value decreases, because as atomic size increases, nuclear attraction on outer electron, not outer shell, that present outside of the atom, it cannot attract that electron easily because nucleus is away from that electron. So now, as atomic size increases, the tendency to attract that electron decreases. So like that, electron gain enthalpy also decreases. But in every group, second element electron gain enthalpy greater than that of first element. That means, for example, if you consider seventh group, chlorine electron affinity greater than that of fluorine. In sixth group, sulfur electron affinity greater than that of oxygen. Why it happened like this means, if you come to fluorine and chlorine, fluorine is having smaller atomic size, comparatively that chlorine is having larger atomic size. Of course, here also 7 valence electrons, here also 7 valence electrons are present. But due to smaller atomic size, these 7 electrons are very close to one another. So, interelectronic repulsion is more. So, now fluorine is showing some repulsion to accept extra electron comparatively with which one? Chlorine. But in case of chlorine, 7 electrons are present, but due to larger atomic size, they are away to one another. So it is having less interelectronic repulsion. So it is easily accept the electron. So like that, due to high interelectronic repulsion, fluorine F electron gain enthalpy is less than that of which one means chlorine. So this is variation of electron affinity in a group. Now let us see in a period. So in a period from left to right, electron gain enthalpy increases. In a period increases because as atomic size decreases, the tendency to gain electron increases. So in a period from left to right, electron gain enthalpy increases. And zero group elements are having zero electron affinity value. That's why only they named as a zero group, because already they have octet configuration. They no need to gain electron. So that's why zero group elements having zero electron affinity value. So this is regarding variation of ionization potential in a group and in a period, and regarding electron gain enthalpy. Okay, bye.